Naive Bayes. This is another machine learning classifier. In this section we are going to talk about the naive Bayes classifier. So far we have learned the support vector machine classifier and the k-nearest neighbors classifier. Now in this session we will talk about the naive Bayes. Naive Bayes is another classifier. It is another machine learning classifier which is doing classification. So let's first go for the introduction. According to the definition that we have, naive Bayes is a classifier which does classification based on probability. It was first coined by Thomas Bayes. As I told you, it is a classifier. It is a machine learning classifier which does classification based on probability. It takes the probability. Based on that probability, it does classification. It was first coined by Thomas Bayes. So this was the guy who first invented naive Bayes classifier. Naive Bayes classifier does classification based on probability. It takes probability and then does classification. Let me show you the Bayes rule. We will see the naive Bayes rule. It is actually a naive Bayes theorem. According to that theorem, we have probability of A given that B has occurred equals to probability of B given that A has occurred into probability of A all over probability of B. This is the naive Bayes theorem, where we can read P of A as probability of A, and this is the probability of B given that A has occurred. This is the naive Bayes theorem. Based on that theorem rule, the naive Bayes classifier do classification. P of A is the probability of A, This is the probability of B given that A has occurred. Look, it is not B or A, don't forget. It is not a fractional sign. You can say that probability of B given that A has occurred, which means that A has been given. We are taking the probability of B where some evidence has been given, which is A. So A has occurred. We are taking the probability of B. And then times probability of A all over probability of B. This is the naive Bayes theorem. Look at here, it is actually P of outcome given that we know some evidence equals to P of evidence given that we know some outcome into P of outcome all over P of evidence. Probability of A given that B has occurred means that probability of outcome given that we know some evidence. For example, we are taking the probability of A, we are taking the outcome, we are taking the probability of A, which is the outcome, where we have some evidence where B has occurred. B has occurred means that we know some evidence. Given some evidence, we are taking the probability of the outcome, which is A. It actually equals to P of evidence given that we know some outcome. Probability of B given that A has occurred, which means that we are taking the probability of the evidence where some output has been given. This time, in this case, we are taking the probability of the evidence, the probability of the B, which is evidence, where outcome has been given, times P of outcome, probability of the outcome, all over the probability of the evidence. So look at here, probability of A given that B has occurred is actually the probability of the outcome given that we know some evidence. For example, my A is outcome, my B is evidence. It equals to probability of evidence given that we know some outcome, which means that B is evidence in this case and A is the output, times P of output, A is output, remember, all our probability of the evidence is the B, probability of the evidence. So this is the simple explanation in simple words. I hope you understand it. But let me give you one daily life example where I have probability of COVID given that test positive equals to probability of test positive given COVID into probability of COVID all over probability of testing positive. This is a daily life example. We are finding the probability of the COVID where test positive has been given. If test is positive, then it is the probability of the COVID. It equals to probability of test positive given COVID, which means the probability of test positive if the COVID is given times probability of COVID all over probability of testing positive. So look at here, my A in this case is COVID. COVID is the outcome. Given that we know some evidence, what is the evidence? The evidence is the test positive. It is the positive test. So positive test is the evidence. Given that positive test, that evidence, we can find the probability of the COVID, which is the outcome. It equals to probability of test positive given COVID. Look, the evidence here is test positive. It is the evidence. If the test is positive, it is very clear evidence that you have COVID. You have suffered COVID. Given COVID, we are finding the probability of the test positive in a case where the COVID has given. If there is COVID, you can find the probability of the positive test times probability of COVID all over probability of testing positive. So the outcome is COVID and the evidence is positive test in this case. So this is the naive Bayes theorem rule. I hope you understand it now.